Unit 4. Can you believe it? We're already at Unit 4. So graphing equations is where we're starting today. And so one of the things we need to talk about when we're talking about graphing equations is the coordinate grid and how do we get numbers on a coordinate grid. So first thing we're going to do is start by making a T-chart. That is going to be our first plan of action. We need to be able to choose at least 3 values for x. So when you look at an equation like y equals x plus 2, a T-chart looks just like that, like a lowercase t. And you've got x values and y values. Sometimes you'll be given those values and sometimes you'll get to choose them. Now, if you're going to choose the values, you want to choose values that make sense. A, that they're going to fit on the graph, but B, that they work for your equation. It'll make a little bit more sense when we get down to the bottom of the page. So let's just choose something easy like -1, 0, and 1. Whenever possible, you want to try to choose a negative value, a 0, and a positive value. That gives you a little bit of an idea of what the graph looks like in different quadrants. So I'm going to say, what do you get when you add x plus 2? So the x value is -1 plus 2, the outcome would be 1. 0 plus 2, the outcome would be 2. And 1 plus 2, the outcome would be 3. That gives me coordinates. So the first coordinate is -1, 1. So I go left 1, up 1, and I put a point. 0, 2. I do not go left or right, but I do go up 2. And then 1, 3. Go to the right 1, up 1, 2, 3. I get 3 points that are in a line, linear. That's good. And then I'm going to connect them with a line and say, oh, okay, that's what the line looks like that's represented by y equals x plus 2. So if you were to pick some other point like up here, that point would be 1, 2, 3, 1, 2, 3, 4, 5. The coordinate 3, 5 falls on the line, so it should make this equation true. Does y equal x plus 2? The y coordinate for that point is 5. Does 5 equal 3 plus 2? And it does. That is one way that you can check whether or not your line works for other points that are on the line. So for right now, we're just going to be doing linear graphs. So you should expect to get straight lines for all of them for right now at the very least. All right, so this one, -2x plus 1. So I'm going to do the same thing. I'm going to make a T-chart. I'm going to pick values of x. Again, 1 negative, 0, and 1 positive is sort of the standard. So this one says multiply the x value by -2 and then add 1. So -2 times -1 plus 1 is what we're substituting. -2 times -1 is 2 plus 1. The outcome would be 3. If I plugged in 0, that would be -2 times 0 plus 1. So 0 plus 1, the outcome would be 1. And last but not least, if I plugged in 1, -2 times 1 is -2 plus 1 would give me -1 as an output. So I'm going to graph the 3 coordinates. -1 is going to be left 1, up 1, 2, 3. 0 means don't go left or right. And then the y coordinate is 1. And then right 1, down 1. So this one's pointing down to the right. The first one was pointing up to the right. So that's a little different. But it is still a straight line. So that's good. We can check again. Maybe we check... I don't know, maybe we check, I didn't quite draw my line perfectly straight. It should be a little bit steeper than what I've got here. So one of the coordinates that should be on the line is right here, which would be 1, 2, 1, 2, 3. So 2, -3. If I check that, does -2 times the input 2 plus 1, do I actually get -3 as an output? So I get -3. -2 times 2 would be -4 plus 1. -3 does, in fact, equal -3, so that works. If I had my ruler and I didn't use it that time, I would have gotten a slightly steeper line. All right, so here's what I meant before about picking good x values. I want to pick numbers that I can easily multiply by 1/4. So instead of picking -1, 0, and 1 like I did above, I'm going to pick -4, 0, and 4. Since I'm going to multiply it by 1/4, I'm actually just making my life a little bit easier by doing this. So down here at the bottom, I'm going to write 1/4 times, my input is -4 plus 1. So what is 1/4 of -4? It would be -1 plus 1, and the outcome would be 0. If I plugged in 0, that's an easy number to multiply by. Anything times 0 is 0. So that'd be 0 plus 1, and my outcome is 1. And then if I plugged in 4, so 1/4 times 4, That's 1 plus 1, and the outcome would be 2. Now, it looks like 0, 1, 2. It should be really close together. But don't forget you picked x values that were not 0 and then -1, +1. So I've got to go left 1, 2, 3, 4, and I stay on the axis for 0. 0 means I don't go left or right, but I go up 1. And then 1, 2, 3, 4 to the right, up 2. So this line is actually not very steep at all because of that 1/4. We picked numbers that were easy to multiply by 1/4. So if you see on the last one on the bottom right, I'm going to do the same thing. This is 2/3. So I want to pick numbers that are easy to divide by 3 since the denominator is 3. So when I pick my x values, I'm going to pick -3, 0, and +3. So what's really happening is 2/3 times -3, and then I'm going to take away 3. So the 3 here that I'm multiplying by and the 3 in the denominator, they cancel. So I'm going to get -2 minus 3, which is -5. I'm also going to have to do times 0. Well, anything times 0 is 0. Minus 3 would be -3. And then I have to do 2/3 times 3, which is the 3 and the divided by 3 cancel. So 2 minus 3 is -1. Now, you're welcome to check this. You could check it on a calculator. Not very easy because it's a fraction, but if you wanted to check it, I can grab a Post-it note here so you can see what's really going on. 2/3 times -3. I'm going to make it look like a fraction and then take away 3. So the 2/3 times -3, I'm simplifying the 3's. 2 times -1 is -2. Take away 3. That's where my -5 is coming from. So just in case you needed a refresher on multiplying by fractions and simplifying them. So when I go to graph this, I've got -3, 1, 2, 3 to the left, down 1, 2, 3, 4, 5, since they were both negative. 0, don't go left or right, but go down 3, and then right 3, down 1. So this one is a little bit steeper than the last one, the fraction being 2/3 instead of 1/4. All right, so when we look at the back, it says to determine if an ordered pair is a solution to an equation, follow these steps. We did 2 of these on the front in red, so this is not going to be brand new. Substitute the x value in for x and the y value in for y. Well, that makes sense. The x value is the first number, the y value is the second number. I do sometimes write that just to make sure I substitute them in the right places. This particular equation is y equals 2x minus 2. We're trying to figure out whether or not this coordinate, 5, 8, is going to make this a true statement. If it were graphed, we're trying to figure out if the point 5, 8 would be on the line for y equals 2x minus 2. So first, I'm going to write the equation that I'm checking. I'm going to substitute 8 for y. I'm going to substitute 5 for x. And then I check to see whether or not this makes a true statement. Does 8 equal 10 minus 2? Does 8 equal 10 minus 2 is 8? And we would say, yes, it is a solution. So that's good news. So if we were going to graph y equals 2x minus 2, the coordinate 5, 8 would be on the line. Next, y equals 2x minus 2. If I substitute -4 for x and -6 for y, I'm figuring out whether or not this is going to make a true statement. So does -6 equal, multiplication comes first. Oops, that's a 2. And -6 equals, now -8 minus 2 is the same as -8 plus -2. If I rewrite it as subtraction, you can see that they are not equal. So we would say this is not a solution. If you tried to graph the equation, -4, -6 would not be on the line. If we have y equals 2x minus 2, same equation, and we're going to substitute 0 for y, -1 for x. Does 2 times -1 is -2 minus 2. Now, some people jump on this one, and they don't take the time to rewrite it as addition. -2 plus -2, 0 does not equal -4. We would say this is not a solution. Last but not least, -7, -16. I really can't picture the graph, and -7, -16 is so far away from the origin that I am going to substitute, just like all the others, negative 16 for y, 2 times negative 7 minus 2. Does negative 16 equal 2 times negative 7 is negative 14. And if I take the extra half a second here to rewrite this as addition, negative 14 plus negative 2 does in fact equal the negative 16. And we would say, yes, negative 7, negative 16 is a solution. If we graphed y equals 2x minus 2, the coordinate 5, 8 would be on the line, and the coordinate negative 7, negative 16 would be on the line.